Hello and welcome to the Math Studio. In this video, we're going to look at piecewise functions, in particular, graphing piecewise functions. So what is a piecewise function? It's a function that takes on various equations depending on the domain of x. So in this example, f of x takes on three different equations, okay, or is defined by three different equations, depending on what the domain of x is. And in this particular instance, f of x equals x for x less than 1, f of x equals 1 for values of x greater than or equal to 1 but less than 3, and f of x equals x squared minus 7, so that's parabolic, for values of x greater than or equal to 3. So maybe at this point you can start visualizing what's going on here. X is a linear, okay, so just before I move the camera to the screen and show you what's going on in Desmos, okay, that's sort of y equals x, or function x equals x. Function x equals 1 is a horizontal line, so it sort of looks like that. And x squared minus 7, right, is a concave up parabola. So really what we're doing is we're sort of bringing those three shapes together and sort of not necessarily joining them together, but graphing them in such a way so that we satisfy the domain given. Okay, so the shape's only extended so far as the domain allows. All right, so what I'm going to do now is I'm going to pause the video. So I'm going to do this now using Desmos. I'm going to pause the video and I'm actually going to show you how to specify a domain in Desmos. Okay, so what I've done now is I've just adjusted the camera and I've pointed it at my laptop screen. Okay, so this is our Desmos screen. So if you recall what the piecewise function was, the first part of the first piece is the function f of x equals x. However, we need to restrict the domain for values of x obviously less than 1. So what we use is the curly brace, the open curly brace there. So you can see that symbol there, okay? And what we're going to type in, actually type in the inequality, x less than 1. Okay, so you can see what's happened is the domain now has been restricted and up to, but not including, x equals 1. So that's why it says undefined there. Okay, so that's the first piece. Now let's graph the second piece. And the second piece was f of x equals 1. So we could just type in, in fact I need to type it in fully, okay, y equals 1. Actually, to do this properly, really what I should do is type in the full equation. Sort of cheating a little bit here. So y equals 1, and we also need to restrict that domain, okay, and this is for values of x greater than or equal to 1. So again, open curly brace, okay, so 1, okay, so now the less than or equal to sign, so we type in sort of less than, but then sort of equals straight after that, and you can see that it actually changes the inequality sign there to a less than, a greater than or equal to, but it's 1 less than or equal to x, of course. And so x is greater than or equal to 1, but x is less than 3. So I'm just making sure I get that equation right. Okay, and you can see here, that's the second piece of the piecewise function. Now for the final piece. So this is the parabolic component. So y equals x squared minus 7. Okay, again, we need to restrict the domain. So hopefully by now you'd be saying open curly brace. There we go, open curly brace, and x greater than or equal to 3. Greater than or equal to 3, and close curly brace, and this is our piecewise function. Okay, so I could probably stretch it out horizontally a little bit more, just so you're able to see the parabola component a little bit. I mean, it's to scale sort of 1 to 1, but if we wanted to, I mean, we could even maybe adjust the x-axis. So instead of from negative 23, I could say maybe negative 5 to positive 5, perhaps. Okay, And that probably, maybe just move that over, that way we can just see the parabola or the parabolic component a little bit more. You can see that between the red and the blue lines, so piece 1 and piece number 2, I'll just point to it. So piece 1 and piece number 2, they're connected. Okay, it's not smooth, but it is continuous. I could draw that without lifting the pencil off the page if I was to do that manually. But we can see clearly that between piece number 2 and piece number 3, that it's disconnected there. So it's sort of a discontinuity. So it's certainly not continuous nor smooth for that matter. Okay, so hopefully that's helped, and especially when restricting domains. So that's how we restrict the domain in Desmos. Thanks for watching.